Good afternoon, viewers and listeners. Welcome once again to Salida Teleradio of the La Filipina National High School. I am your teacher host, Carl Marie Joyce Bandoy. And this afternoon, you will learn many things about inverse, converse, and contrapositive of an if-then statement. Lesson in Mathematics 8, Quarter 2, Module 7. Are you all ready? Let's give the floor to our teacher broadcaster, Edward Morin.
Thank you so much, Ma'am Carl Marie Joyce. Hello, viewers and listeners, especially to our grade 8 learners. Welcome to Salida Teleradio. I am Teacher Edward P. Moring, your math teacher for today. Are you ready to learn a new topic in mathematics? Then, brace yourselves as we traverse our journey to inverse, converse, and contrapositive of an if-then statement, especially in identifying the pattern of inverse, converse, and contrapositive of an if-then statement. Writing the inverse, converse, and the contrapositive of the conditional statement. And lastly, creating examples of if-then statements with their converse, inverse, and the contrapositive statements. Have you watched the episode of Salida La Filipina TV with Teacher Lorelei? Well, she discussed about the conditional statements, commonly known as the if-then statements. For a quick refresher, let us review the previous concepts we need to proceed with our topic today. Conditional statements. These are formed by joining two statements P and Q using the words if and then. It is composed of two clauses, the if clause P, or represented by the small letter of the English alphabet, and then the then clause Q. This statement is in the form of if P, then Q. P statement is called the hypothesis, and the Q statement is called the conclusion. That is, if hypothesis, then conclusion. Are you still with me? Now let us try the following examples. Let us try transforming the given hypothesis and the conclusions into if-then statements. Carla will come to school early. This is our hypothesis. Again, Carla will come to school early. And our conclusion is she will be a watch awardee. Again, she will be a watch awardee. If we are asked to transform this one into an if-then statement, then it would be, if Carla will come to school early, then she will be a watch awardee. Let's take the second example. For our hypothesis, we have Jana is Amandaya. Again, Jana is Amandaya. That means Jana belongs to Amandaya tribe. And for our conclusion, we have she can speak fluently Minandaya. Again, our conclusion, she can speak fluently Minandaya. And if you are asked to write this one into the if-then statement, then it would be, if Jana is Amandaya, then she can speak fluently Minandaya. And for our third example, I would like to emphasize that conditional statements are not always in the if-then form. However, these can be written in that form for easier identification of the hypothesis and the conclusion. Let us say, for example, in the slogan, "No to drugs, yes to life," it is not written in the if-then statement form, but we can still see or identify the hypothesis and the conclusion. We may have the same hypothesis and conclusion. So I have here, Alvin says no to drugs as the hypothesis, and he says yes to life as the conclusion. Then, if you're asked to transform this one into if-then form, it would be, if Alvin says no to drugs, then he says yes to life. Now, let's deepen our understanding by learning the three related statements of an if-then statement. These three related statements are the converse, inverse, and the contrapositive. Given an if-then statement, if P then Q, we can create these three related statements. Let us take our first previous example and transform it into its converse. To form the converse of the conditional statement, interchange the hypothesis and the conclusion. Since our conditional statement is, if Carla will come to school early, then she will be a watch awardee. Thus, the converse of this statement is, if Carla will be a watch awardee, then she will come to school early. Remember to interchange the hypothesis P and the conclusion Q. In symbols, that is, if Q, then P. For the inverse, to form the inverse of the conditional statement, take the negation of both the hypothesis and the conclusion. Using the same example, let us try to transform it to its inverse. Since our conditional statement is, if Carla come to school early, then she will be a watch awardee. Thus, its inverse is, if Carla will not come to school early, then she will not be a watch awardee. Now let's have the contrapositive of the given if-then statement. To form the contrapositive of the conditional statement, interchange the hypothesis and the conclusion of the inverse statement. Thus, the contrapositive of the statement, if Carla will come to school early, then she will be a watch awardee. So, its contrapositive is, if Carla will not be a watch awardee, then she will not go to school early. Now you already have ideas on how to transform if-then statements into their related statements. Now let's apply what we have learned in terms of geometry. Transform the following if-then statements into converse, inverse, and contrapositive. This is now the if-then statement. If two angles have the same measure, then the two angles are congruent. Again, if two angles have the same measure, then the two angles are congruent. So first is, we have to identify the hypothesis and the conclusion, or identify P and Q. So our hypothesis for that if-then statement is two angles have the same measure, while our conclusion, or the Q, is the two angles are congruent. Now let's transform the if-then statement. Since the original if-then statement is, If two angles have the same measure, then the two angles are congruent. So that is P implies Q. And our converse, which is Q implies P, if the two angles are congruent, then the two angles have the same measure. Again, if the two angles are congruent, then the two angles have the same measure. For the inverse, we have that is not P implies not Q. So that would be if two angles do not have the same measure, then the two angles are not congruent. Again, if the two angles do not have the same measure, then the two angles are not congruent. And lastly, for the contrapositive, that is not Q implies not P. If the two angles are not congruent, then the two angles do not have the same measure. Again, if the two angles are not congruent, then the two angles do not have the same measure. Let us remember that in the conditional statement of Q by P, it is written in the form of if P then Q, or P implies Q. And it is denoted by P, an arrow from P going to Q. It is false when P is true and Q is false, otherwise it is true. For the converse, let us remember that suppose a conditional statement of the form if P then Q is given, then the converse is if Q then P. Symbolically, the converse of P to Q is Q to P. Now for the inverse, suppose a conditional statement of the form if P then Q is given, then the inverse is if not P, then not Q. Symbolically, that inverse of P to Q, or P implies Q, is not P implies not Q. For the contrapositive of a conditional statement of the form if P then Q is if not Q, then not P. Symbolically, the contrapositive of P implies Q is not Q implies not P. Did you get it? So let's proceed to our assessment. Now prepare your ball pen and your paper to answer the given items. Transform the given statement into its related statements. Crash out or strike through its hypothesis and underline the conclusions. The given conditional statement is if two lines form right angle, then they are perpendicular. Again, if two lines form right angle, then they are perpendicular. Now it's your time for you to transform the given conditional statement into its converse, inverse, and contrapositive. And your time starts now. Okay, your time is up. The conditional statement, if two lines form right angle, then they are perpendicular. And its converse is, if two lines are perpendicular, then they form right angle. The hypothesis is, two lines are perpendicular, and the conclusion, they form a right angle. For the inverse, if two lines do not form right angle, then they are not perpendicular. The hypothesis, two lines do not form right angle, and the conclusion, they are not perpendicular. For the contrapositive, we have if two lines are not perpendicular, then they do not form right angle. The hypothesis, two lines are not perpendicular, and the conclusion, they do not form right angle. Okay? For your assignment, make your own example of an if-then statement and get its converse, inverse, and contrapositive. Then, you may pass your output in your respective math teacher. And that ends our episode for today's Salida Teleradyo. If you have questions, you may clarify them with your math teachers. Thank you so much for watching and listening. I am Teacher Edward P. Morin, bidding you goodbye for today. Have a nice day.
That was great! Thank you, Teacher Edward. And thank you, viewers and listeners, for tuning in. I hope you have learned something today. Once again, I am your teacher host, Teacher Carl, saying, if math is hard and so is life, then get over it. Have a nice day. Bye-bye.